Right, so here I am at the end of my week-long challenge to learn how to use and program the Arduino microcontroller. This is one of those. This is the Arduino Nano, which is a very small package programmable microcontroller, which is basically a little microcomputer. And the reason why I wanted to learn how to do this was to sort out a problem that we've got on the farm. Basically we need water for irrigation things, and we're off-grid, so what I decided to do was to see if we could put a little well in, which we have managed to do. It's a little well. It's basically a 4-inch wide well that goes down into the sand of the water table and therefore fills up with water. So we've got water there, but it's only in a small quantity, and if you pump too much out, basically the water level drops down and the pump runs dry and you have to wait for it to fill back up again. So what we needed was a solution where we could pump the water up this pipe through the pump and into the tank and keep the tank filled up. So the problem was, if the pump keeps pumping, it runs the well dry. So this is where I came up with the idea of using the Arduino to control the pump. So what we've actually got is a switch which is down the well here, float switch, and when the well gets pumped empty, the switch opens, closes, I think, from memory. Yeah, switch closes and turns the pump off, and then it waits for so long until the water level comes back up and then it starts pumping again. The other sensor is is in here at the head of the tank. So what happens here is it measures the water level in the tank. If when we draw water off to do our irrigation through the tap here, then the water level falls, and what we wanted it to do was to sense the level falling and to start the pump up, switch the pump on, and bring the level back up so the tank is always full. So when we're not there, after we've used water, it can be pumping away and doing this thing where it's switching the pump off and then back on again. So all this needs controlling, and the little microcontroller is in there. So what we've got here, this is the, oops, squeaky chair. This is the breadboard microcontroller board, which is where I made my mock-up from, and that's the actual microcontroller mounted on a kind of test bed. And now I've gone actually made the thing. So I've written the program and tested it, made it work, and actually made a version which is going to be situated in the well. So we've got a red light at the moment. That means the well is pumping. That's controlled. The actual height of the water, let's get off this chair. The height of the water is controlled by this unit here, which is an ultrasonic sort of sonar detector. And it's set up, it basically sends a sound wave out of one of those little transducers, bounces off a surface, and then times the response to come back. It works a bit like sonar. Well, it is sonar. And it takes the time and it works out the distance. So if you can imagine that this is sat in the top of the tank. So what actually happens, if we go over to the board there, we've got a red light at the moment, which means that the pump is running. Because if you look at the distance between the table, if you imagine the table top is actually the top of the water, and the little transducer here is well above water level. What actually happens is, as this comes down and the water comes in contact, you hear a click there, and then we've got a white light here. That tells me that the water level has risen and has cut the pump off. If I raise it back up again, the red light comes on, so the pump's back on running again. As the water comes up, it clicks off, which is fine. So if I point that up at the ceiling, that's the pump running all the time now because the water level is very, very low. If I then want to test out, find a little piece of wire. If a little piece of wire here. The switch then in the bottom of the well, which is here. So what I want to do is simulate what happens when the well is empty. Put a little short across those contacts there, because these contacts will connect right the way through. Oops, they'll connect right the way through to the bottom of the well. Put a little short on there, which is difficult to do with one hand. There we go. Oops, let's try this again. Try filming and doing it at the same time. There we go. So that's it, click. So that represents the switch at the bottom of the well. Closing, and now there'll be a delay. I can program this delay as long as I want. At the moment I've set it for 30 seconds. So after 30 seconds, the little red light should come back on, which means that the pump will be back on and we'll be starting to pump water again. When we actually test this, we'll see how long it takes for the well to fill up. And there you go, comes back on again. So yeah, we'll test how long it takes to fill up and program in the right size, sorry, the right time delay. And that's it. So we've actually got the thing to work.